Alright, lesson 9.2 is on arithmetic sequences. It's a specific type of sequence where you're going up by the same amount or down by the same amount each and every time from number to number. That amount you go up or down by is called the common difference. And the common difference is going to be denoted by the letter D. Now these sequences, the work we do today is going to be nothing new to you. Because these sequences are essentially linear sequences. So back in the day when you dealt with all the ways to find y equals mx plus b, those are the same types of things that are going to happen here, apply here. Sometimes I'll basically give you the slope and the y-intercept. Sometimes I'll give you a slope and a point. Sometimes you get 2 points. Only here, it's just different verbiage, different notation. So D, common difference, that basically goes hand in hand with slope from the past. So slope, which was m. And then we're also going to need to know a sub 0. Now a sub 0, that's the 0 term, that's the term to the left of the first term. So that's essentially the y-intercept in our old y equals mx plus b equation. Well, instead of y equals mx plus b, this is what we have right here. A sub n equals a0 plus dn. I kind of got it mixed up. It'd be more like if I had y equals b plus mx. That's what this looks like down here. Because a0 is b and d's are m. And n is like x. N is what, that's the most important thing here, is to understand that n is like x and a sub n is like y. They're an ordered pair. So instead of having an x and a y, you're going to have an n and an a sub n. So we plug in for n, and we get an a sub n. Now the book formula is a little bit more lengthy. You may see this formula in other places as well, so I think it's important for me to point that out. So if you see it, you're like, man, I've never seen that before. But the book formula, if you expand it out, distribute that d, ends up giving you the exact same thing, because if you take a1 and combine it with minus d, that's going to take you back to a0. So normally we got plus d. If you add d, that brings you to the right. That brings, you just say, well, say d is 2. You're going to go 2 to the right each time. But to find something to the left, you would subtract it. So I'm just saying that this minus this is equivalent to this a0 that I have here. This is going to make our work a little bit shorter. Let's go ahead and just use that. All right, let's get to the examples. How do we know if something's arithmetic? I'll determine if it's arithmetic. You need to, I'm going to scoot this over a little bit. Hang on. Okay. You need to have a common difference. Called the common difference because to find how far apart things are, you subtract. And technically the common difference is found by taking some term and subtracting the term to the left of it. So take some a sub n and subtract a sub n minus 1. So what that means is we could take the 7 and subtract 10 and we'd get negative 3. Or we could take the 4 and subtract the 1 to the left of that, minus 7, and get negative 3. Or we could take the 1, subtract 4 from that, and get negative 3. So you might be thinking, hey, common difference is the same. It's negative 3 every time. But it isn't. It isn't negative 3 every time, because when you get to the end, you get negative 2. So because these here are different, so they're not the same, so you have no common difference. So since you have no common difference, it's not arithmetic. All right, so I got a little interrupted there. Sorry about that, but I'm back. No common difference. So, not arithmetic. You have to have this, it has to go up or down by the same amount every single time in order for it to be arithmetic. And this one doesn't, so it's not arithmetic. Moving down to the next one. Is there a common difference? Does it change by the same amount? I don't know. I could see it goes up 5 here, it goes up 5, and it goes up 5. So that's really, if I know what it goes up or down by, I don't need to show the subtraction. Hopefully you can see that it goes up 5 every time. So this one does have a common difference. D is 5. And when you have a common difference, I want you automatically thinking, hey, let's use that formula that Mitchell gave us to use and plug in what we know. So we know D is 5. Well, in order to finish these formulas, what you need to know besides D is A0. If you know A0, you're done. Now, you could plug in one of these points, and that's the significance of their formula. They're saying, you know what, we'll just plug in A1 up here. You know what A1 is. We'll just plug in a negative 11. Well, I'm saying rather than plug that in and work backwards, just realize that all you're trying to do is figure out this number over here. What would go over here to the left of negative 11? Well, to get there, you would go negative 11 minus 5. It'd be negative 16. You go 5 the other way. So I plug that in here, and there's my formula, my rule. I can verify that it works. I can plug in something, and I'll say I want to find A sub 3. A sub 3 should be negative 1 because it's the third term in the sequence. So if I plug in 3, do I get negative 1? I get negative 16 plus 15. That's negative 1. So it works out. And if you plug in into the other ones, it's going to work there as well. Okay, moving on. Next one you're told is arithmetic. So since you're told it's arithmetic, you can go ahead and just say, I'm going to use A sub n equals A0 plus dn. And I'll plug in what I know. Well, I know that d is negative 2, but I don't know A0 on this one. Now you might be thinking, well, I could just find A0, I could work backwards, because you could be saying A2 is 8, and A1 then would be 2 the other way, you know, because A3 would be 2 down, so this would be 6 because D is negative 2. Ooh, that was crazy. D is negative 2, so that tells me go down 2 as I go to the right, so I go up 2 as I go to the left. So you might be able to reason this out and say A0 is 12. And that's great because you understand what's happening. But what if I would have said, you know, A sub 207 is 8? Do you want to be counting back to A0, or do you want to figure out what to do mathematically? I'd be all about figuring out what to do mathematically. What should we do here? Well, A sub 2 equals 8 is basically an ordered pair. It's telling you if you plug in 2, you're going to get 8. So you have an input of 2 and an output of 8. So you plug 2 in, you should get 8 out. A0, a little solving going on here, add the 4, and you get A0 is 12. Excuse me, mathematically. Don't celebrate there, you have not finished the problem, you've just found A0. You need A0, you need D, plug them in, do a little formula here. So you got A sub n equals 12 minus 2n. There's the formula. I've got a follow-up question up there saying what is the 20th term? What's the 20th term? So that just means find A sub 20, which means plug in a 20. 12 minus 40, you get the 20th term would be negative 28. Okay, let's readjust it a little bit. And we'll move on to the next page. Example 3 is basically the same thing as example 2. I would encourage you to go ahead, try this one on your own, you know, do a little pause action here and then come back and see if you got it right. Alright, so we've got, it's an explicit for an arithmetic, so when it's arithmetic, we're thinking this formula here. I've got D is 9, and here I'm telling you the 14th term is 30, so I'm going to plug in 14, we plug in to the right-hand side, and we get out a 30. 9 times 14 is 126, subtract 126, get negative 96, and our formula then would be A sub n equals A0, which is negative 96, plus dn, and d is 9. There's our explicit formula there. Now, I should have put an example for a recursive formula on here as well. Let's go ahead and, hopefully you got a little room, let's just put a recursive formula down here for this problem. Let's make a note that for recursive, all you do is write down what's happening. So in this pattern, we were going up by 9s. So as I go to the right, I add 9. Well, that's all I got to put is plus 9. So to find a term, I take the 1 on the left, that's what a sub n minus 1 means, and I add 9. Now you got to tell me what a1 is. Otherwise, it doesn't mean anything. Now you got to give me a starting spot. So how do I find a1? Oh, I've got a formula right here. It works for any a sub anything. I could plug in a sub 10, a sub 100. If I want to find a sub 10, I plug in 10 over here. If I want to find 100, I plug in 100 right here. If I want to find a sub 1, just plug in 1 right here. Or you could say a0 is negative 96, add 9 to that, and you're going to be at a1. So negative 87. That would be the recursive rule if I wanted recursive. So in general, recursive is just, for arithmetic, is just a sub n minus 1 plus d. So whatever d is, you're going to add that to the previous term. Okay, this one here does not have a common difference, and it does not have a0. I need to find both of those. So I can find the common difference. Well, I can reason it out. I could understand that this means 71 is the 24th term. You know, so there's actually 23 numbers to the left. And then the 51st term is 179. And then say, okay, so what I'm doing is I'm making a huge jump here using addition. From 71 to 179, I'm using addition. Well, how do I get from 71 to 179? I add, subtract those, I get 108. I need to add 108. So this is one huge jump of 108. I don't want to make one huge jump. I want to make a bunch of little equal jumps in here to get to 108. They have to have the same difference. That's why it's a common difference. So the question is, how many jumps are there? Well, it goes from 24 to 51, so we'll go 51 minus 24. There are 27 equal jumps. 108 total, 27 equal jumps. They must be 4 each in size. And that's your D. Now that's the reason behind it. Let's go back and look at another way, to think about it. These are essentially ordered pairs. Plug in 24, I get 71. Plug in 51, I get 179. And what you can do then is say, common difference is basically slope. How do we find slope? Oh yeah, y minus y over x minus x. And that's all I did here. Y minus y over x minus x. So once I have d is 4, then I can go ahead and plug that in to my base equation, and then repeat the work that we've done in the previous two problems. Plug in one of these points, either one, doesn't matter. So let's go ahead and plug in 24 and 71 because those numbers are smaller. 71 goes in the output spot, and 24 goes in the input spot. Four times 24, 96. Subtract 96. A0 is negative 25. Therefore, a sub n equals negative 25 plus 4n. So you write that final formula, it's got the a0 and it has the common difference in there as well. Put some stuff in here from class, let me get that erased off. Last problem. Pretty basic. It's kind of a review of the notation here. A sub n minus 1, a sub n plus 1. What do they mean? Well, they just mean the numbers that are to the left and to the right of a sub n. So if I had a sub n in the middle, I'd have a sub n minus 1 over here, and I'd have a sub n plus 1 over here. And I want to find a sub n, that's my x. But I know this is 25. And I know this is 41. So if it's arithmetic, what do we want to do? Well, you could say I make a jump of 16. One big jump of 16, but really I'm making two small jumps. So each small jump would have to be 8. And then 25 plus 8 is 33. That's one way to get it. Or you could use the arithmetic mean, which is just the average. You could say the numbers in between 25 and 41. Add them up, get 66 over 2, and that's 33. So you got options on that one, but the assignment will refer to arithmetic mean, which is just average. There's one more like these, where you might have one number and then 3 in between, and you want to find the 3 missing numbers. You can use the formulas, or you can realize that because I'm telling you it's arithmetic. If they tell you it's arithmetic, just realize that this number in the middle is the average of these two. And what's the average of 10 to 20? 15. 10 plus 20 is 30. 30 over 2 is 15. And then when I go to this one right here, that's the average of these two. What's in the middle of 10 and 15? Oh, that's 12 and a half. 25 divided by 2. And you can see the common difference on this one now is 2.5. It goes up by 2.5. So 15 plus 2.5 is 17.5. Or you could average those two. So there are some problems like that on your assignment where you either find averages or find a common difference, treating it like slope like I did up above. So that wraps up section 9.2. Thanks for watching. Have a great day.